Good morning, everyone. Welcome to our class after the typhoon signal number 8. Hope you had a great time yesterday. So starting from this class, we will go into the advanced Python for AI. Actually, it's somehow a crash course. As you can see, there are like more than 100 pages for this lecture. Yeah, that's what you need to know before you really start to learn some AI models. Otherwise, you will only know some conceptual about the AI model, but you'll never know like how to implement it. So that's why we have to introduce this advanced Python, this lecture, after we have a brief introduction to AI. All right? So let's start. Why more Python? Actually, I already explained in the first class, but let's motivate you again. So you already have taken like COMP2211 or COMP2211P because like you enrolled this course, so you must fulfill the prerequisites. So basically, you can program in Python, right? But think about this. You have been learned Python, mostly Turtle in COMP2211, but can you write AI programs? Can you write AI programs using Turtle? It's very hard. So you have learned some basics of Python, of course, with a brief introduction. And you can write some small Python programs, but that's not enough. So in this lecture, we will give you a crash course on some more advanced Python programming elements and some other essentials for writing AI programs. So let's start with some more advanced Python programming elements. First, about the Python versions, know that in 2020, Python has officially dropped support for Python 2. That's already 5 years ago. So if anyone is still using Python 2, I just kindly recommend that you can simply give up Python 2. Like after Python officially dropped Python 2, that means no official maintenance for Python 2. Or if you meet any bugs, any errors in Python 2, and there is just no one responsible for that. Even if you just read some issue, no one will reply to you because like they already officially announced that. So please move to Python 3 if anyone here is still using Python 2, okay? And for this course, all codes will use Python 3.11.13. This is the Python version used by Google Cloud currently. And know that the latest version is Python 3.15.4, which was released in June 2025 this year. You can check your Python version at the command line after activating your environment by running this line of code. So first import system, SYS. It's a Python standard library to check your Python system. And then print this system.version, then you can see your Python version. Then next about the data types, and there is a very useful function called type. So like most languages, the Python has a number of basic types, including integers, floats, boolean, strings, and containers, including the list, dictionaries, sets, tuples. All these are like the data types you can use in Python. And if you have learned C++, of course you know that C++ also support all those data types. But in Python, we use such function, which is called type. So this function can return the class type of the argument or the object passed as parameter. Usually, we use this function type for debugging purpose. That is, if you find some bugs, maybe with regarding to your output, your results, usually the first step is to check the data type of the output to see is there anything wrong with the data type. We can use this type for debugging purpose. Syntax would just be like this: type, pass the object to this function, and you can see the data type of such object. So for example, if we claim x to be 3 in Python and print type x, you will get the type is int, meaning that, okay, now this object 3 is an integer in Python. Like if we claim y is 3.14 and print this type y, it will return float. So mean that, okay, now it's a float object, and if we let z be true, Actually, it's a Boolean variable, right? So after print type C, you can see it's a bool. A Boolean variable means that it can only be true or false, or 1 or 0. Then if we claim such string to become 2211, the type of this string is simply a string. And note that except from all these basic types, Python also supports some containers. So later on, this is an example about container. If we define L to be such a list, 1, 2, 3, consisting of 3 elements, print this type of L, it will return us the list. So meaning that, okay, now L itself is a container, which is a list. If we define D to be such variable, actually, as we can see, it's a dictionary. Cat, cute, dog, furry, D is here. And after print this type of D, we will get the dictionary. A dictionary means that there is a key and a value and they pair with each other. Like in this dictionary, cat is a key, cute is the value, and dog is another key, furry is dog's value. This S is 1, 2, 3. You know that the dictionary and set, both of them use these big brackets here. But in set, there is no concept like key and values. So in the set, all the elements, they are the elements in the set. So if we print type of S, it will return, okay, S is a set. And last, if we define T like this, 1, 2, 3, the small parentheses, the type of T is a tuple. So the tuple will all be contained in such a container with small parentheses. This is the tuple. So the first function. And next, I would like to introduce the list comprehensions. Because if you have taken COMP2211, then maybe you know how to create a list, right? You just use these square brackets, and inside the square brackets, you just put all the elements inside. Then you can create a list. But usually that means you need to enumerate all the elements in the list to create one. If, for example, if you want to create a list consisting of integers from 0 to 12, then you need to enumerate 0, 1, 2, 3, 4 until 12. But for the list comprehensions, it offers a shorter syntax. When you want to create a new list based on the values of some existing list. So let's see how to use this list comprehension. The syntax would be like this. New list name, which is the name of the new list you want to create. And you still need to use these square brackets to include everything for the list comprehension. So usually we just use the square brackets to represent, okay, now it's a list. So inside this square brackets, and we have this expression for elements in some list name if condition. So as we can say, actually, in this case, we do not enumerate the elements, but we will use some keywords like for, in, if. So list comprehension must start and end with the opening and closing square brackets. The specific meaning of the parameters. First, the expression. Expression is the operation we perform on each value inside the original list. And the element here is a temporary variable. So actually, you create it, you name it. It's just a temporary variable we use to store for each item in the original list. Then the original list is here, list name. This is the name of the list that we want to go through, the original list. So that is you operate some operations in this original list. And there is another if expression. So in this condition means that if the condition evaluates to true, then we will add the process element to the new list. And of course, at the end, you will get a list named with this new list name. And note that this if is conditional and is optional. So that means sometimes actually if you don't need such if statement, you just simply drop it. No need to add it always. And this for might contain multiple. So there might be some additional for clause to create such list comprehensions. Yeah. So if I just explain this to you, it's just too boring, too abstract. So let's see some examples here. First, let's say a very simple example. Consider such list. So we already have this old list which calls nums. As we can see, it consists of 5 integers from 0 to 4. And we want to create a new list that is the square of the original list. Of course, we can use the for loop, right? We can always use the for loop to do something like this. So the squares, first we claim it to be an empty list. After that, for all the elements in the nums, for x in nums, we let squares append x square like this. After that, after the for loop, we print the squares and we can get what we want, 0, 1, 4, 9, 16, the squares of all the elements in nums. But actually, we can make this code simpler by using one line of code by using the list comprehension. If we have the nums, still the nums here, then we let the squares be like this. So we use list comprehensions. The operation is that x square. By the way, if we use this double stars, then that means the square in Python. We operate x so that we compute square of x, and for all the x, this is a temporary variable. Basically, for x in nums is the same with here for x in nums. So for x in nums, we do this thing, and then we print squares. Actually, it does the same thing with the above for loop. So note that if we use list comprehensions, actually we still use for loops. Inside these square brackets, actually we have for loops. So theoretically speaking, it cannot reduce the cost, the time cost. But still, if we write in this way, it will be more convenient for us. Because now we shorten this code a lot. We just need to use this one line of code to express these for loops. And list comprehension can also contain the conditions, the optional if statement. So nums, this list again. And suppose now we only want to get the squares of the even numbers of this list. Then we get this even square using such list comprehension. So basically, the first half would be the same, still x square for x in nums. But now we only want some even number square. So we add this if statement. If x modulo 2 is 0, so that means x is an even number. And after that, we get the even squares like 0, 4, 16. So it checks whether x modulo 2 is 0 or not, and it will select 0, 2, 4, these 3 elements to compute the squares. So this is the list comprehensions. And similar with list comprehensions, we also have dictionary comprehensions. And now the dictionary comprehensions can allow us to easily construct dictionaries. Like here, again, we have such nums. Then we create a dictionary directly from the list using dictionary comprehension. So we want to get a dictionary which is called even number to square. As you may infer from this name, now we want to select all the even numbers from the list and compute the square as its values of the keys. All right, so now we get the expression like this. Since it's a list, since it's a dictionary we know that we always need to have the key and value. So here we need to write the expression like this. So x is the key, x squared is the value. And since it's a dictionary comprehension, so we must include everything inside these big brackets. So like this. And the remaining will be the same with list comprehension. Still, we have this for loop for x in nums, and we have this if statement if x modulo 2 is 0. So we select all the even numbers, compute its squares, and get them to be the key and value pair. And so we create a new dictionary. If we print that, we can get such a result. So it will be 0, 0, 2, 4, 4, 16. There are 3 pairs of keys and values in such dictionary. And like lists and dictionaries, we can also construct sets using the set comprehension. So basically, this would all share the same logic here. But now we use a new function. So it imports Actually, later on, I will also introduce what is this import. But for now, just accept that, okay, now we import something. From a library called math, we import a function square root. And for this square root, it's used to compute the square root of some values. And the nums, this is a list this is a set we want to create using the set comprehension. Note that in set it also start with and end with the big brackets. And inside this set comprehension, we do such operation. We get the integer. Here, integer, this means that we will force some data type to be the integer. And inside this integer, we have the square root of x. Then what is this x? X is all the elements we will select from range 30. Range 30, so I guess you already know this function range, right? I think this should supposed to be learned by you before. The range 30 is a Python function which will return all the integers from 0 to 29. Because the starting is 0 if we do not indicate the starts. And the end actually is an open end. So that means it won't include 30, this number. So actually, in this range 30, there are 30 elements from 0 to 29. All right, so for x in such a list, we select x, compute the square root of x, and then force it to be some integer. So we create the set comprehension using this. Then if we print the nums, you will see that the result would be 0, 1, 2, 3, 4, 5. Only these 6 elements. But of course, we know in the original list there are 30 elements. So anyone knows why we end up with these 6 elements? Like why? Yes, please.
It's only up to like 25, which can be square rooted to an integer. It starts from 0.
Yes, starting from 0.
Goes up to 29, but
yes, 29.
25 is the highest number that can be square rooted to an integer.
Yes, but the explanation is not complete. But actually, you indicated one thing, that if we consider all the square roots from 0 to 29, actually the maximum should be 5. But actually, for the elements like 29, it will also compute a square root value.
Yeah, so
but force it to be 5. Yes.
But then why would there be, why would they not list duplicates?
Yes, very good question. Anyone knows? Anyone can respond? Yes, please.
Because sets don't allow multiple same elements.
Yes, excellent. Yes, so I think that can answer your question. Because set does not allow repetitive elements. So if there are 2 same elements, the set will just get 1. So that means even though we know that the square root of 25 is 5, the integer of square root of 26 is still 5, the integer of square root of 27 is still 5, until 29, actually they all get 5. But since set does not allow repetitive elements, so actually it only maintains this one element 5, and the same for the previous from 0 to 4. That's why after the set comprehensions, actually we only get these 6 elements. It will directly drop all the repetitive elements, just keep 1. It will be very different from the list. Suppose we create another one like this, so maybe I can directly add something here. All right. Suppose we do the same thing, but now we use list comprehensions. Okay, and therefore x in this range 30. We create a list using list comprehensions like this. So now we use square brackets. Then after that, if we print this nums list, actually there will be 30 elements. So that is, it will get the square root of 0 is 0, the square root of 1 is 1, the square root of 2 actually is like 1.4 something, but after force it to be integer is still 1. So after that, this nums list contains 30 elements, and this is because the list allow repetitive elements. Like even you have like multiple the same elements, but for the list they are different. The key reason is that list has order. The elements in the list, they have order, right? So the first element in the list is the list 0. The index is 0. The second element index is 1, so on and so forth. But for the set, all the elements, they do not have order. You cannot say like set index with 0 because basically all the elements in the set, they do not have the orders. Like the orders are meaningless in set. All of them are just elements with the values, and the values, they cannot be repetitive. So this is for the set comprehensions, and please pay attention to the difference between list and set. Yes, very good. Next, we would like to introduce the difference between list and tuples. A tuple is in many ways very similar to a list. One of the most important differences is that tuples can be used as keys in dictionaries and as elements of sets, but lists cannot be done like this. Here is an example. The dictionary D is like this, so we use this dictionary comprehension. Now the key is a tuple, as we can see, x plus 1. This is a tuple. A tuple is just you incorporate different elements inside the small parentheses. This is a tuple, and the value is x. And for x in this range 10, it's a list consisting of 10 elements from 0 to none. Then we create a tuple T, which is 5, 6. Of course, if you print the type of T, it will tell you, okay, this T is a tuple. Then if we print this DT, that is, we will pass this T, this tuple 5, 6, as a key to extract its value in the dictionary D, then it will print 5. So the value of this key is 5 after we extract it from the D. And of course, we can directly extract the value of some tuple, like print D 1, 2, then it will get us 1. So that means, okay, now the value we extracted from the D for this key is 1. So we can do this for tuple. So tuple, we can use it as a key in the dictionary. But if you use list here, like if you replace this small parentheses with some square brackets, then it will return error because the list cannot be used as keys in dictionaries. And also for the elements of sets, the list cannot be elements in sets, but the tuples can. Yes, please?
Wouldn't this logically make sense without 4x in range 10 as well? But is it just there because it's a requirement for this comprehension?
Yes, this 4 is...
Kind of useless, isn't it? Because we can have like range 6 as well, it will still work.
Yes. This is just mandatory for the dictionary comprehension. Yeah, for the list, set, and dictionary comprehensions, we must have this for loop. We must operate the elements in some original list. So that's why we must include this for loop here. Yeah, but of course, for this example, if we replace this 10 to 6, still everything works the same. Yes. Yeah, very good. Thank you. So pay attention to the difference between lists and tuples, even though they are very similar actually, right? Like the tuples, they also have the orders. You can index to extract the elements from the tuples, like some tuples 0, tuples 1, you can index it. And for more details about tuples, you can check this one, check this link here. All right, so before we go into the next content, so until now, any questions regarding the comprehensions and differences between lists and the tuples and possibly sets and dictionaries, of course?
So in the last line, the tuple 1 and 2 is replacing the uppermost tuple x and x plus 1, right?
Yes. Here D, actually after we create the D like this, we can print out the D. And then we can see that In total, there are 10 elements in this, or 10 pairs of keys and values. And the first one would be 0, 1 to 0. And the second element would be 1, 2 to 1, and something like that. So actually, this 1, 2 is also a key in the dictionary D. Yes, very good. Thank you. Any other questions? Great. If no, then let's continue. The parallel iteration. So actually, this is another useful method called zip. This zip method takes some iterable, or we say the containers, and returns a single iterator object. The magic thing here is that it can do the automatic mapping. It maps the values from all the containers. You may ask that, what if the past iterable containers have different lengths? Don't worry, even they have different lengths, the zip can work. So the one with the least items or the shortest length decides the length of the new iterator. The syntax would be, you can pass as many iterators as you want to this zip. And after that, it will automatically map the elements from these iterators one by one according to their order. And all these iterators are some iterator objects that will be joined together. Let's see some concrete examples. So suppose we have one list, fruits. In this fruits, we have these 5 elements. So apple, peach, banana, guava, and papaya. 5 fruits here, and of course the list, they have order, right? And we have another list, colors, containing these 5 elements, red, pink, yellow, green, orange. All right, 2 lists. Lists are containers or some iterable objects. Iterable objects that they have the index. So we know that the first element in fruits is apple. The first element in colors is red. All right, now what if now we want to map all the elements together one by one? Then we simply do this thing for name color in zip, fruits, colors. Now, if we use this zip method, fruits, colors, we will combine these 2 lists together, do one-one mapping between the elements. So the zip fruits colors, since we pass 2 iterators here, so that means each element actually consists of 2 things. So we use this temporal variable, name and color, and we can print that. Print name is color. We extract the 2 elements from the zip. And after that, it will print such information here. Apple is red. Apple, the first element here, red, the first element in colors. The second is peach is pink. Peach here, pink here. And the third one, banana is yellow. So it maps banana with yellow, and so on and so forth. So as we can see, it automatically maps the elements in the iterators, of course, according to their orders, since they are all iterable containers. Yeah, and I emphasize again, it's okay if you pass the iterable or containers having different lengths. So for example, if here we do not have this orange, maybe we'll do that. Okay, here. If we do not have this orange, if for the colors we only have 4 elements, then after we run this for loop, of course, it will run. The zip can take different length iterators, but note that now we won't have the last line of print information, because the zip will only take the iterator with the shortest length to decide its output length. So that means, okay, the colors, if it only has 4 elements, then this zip will also return 4 mapped elements. So that means this papaya actually do not have anything to map with. So note the, yes, what if the iterator had different lengths? All right, any question regarding the parallel iteration? Yeah, it's a very useful function. Actually, it can take multiple iterators at the syntax here. You can just pass as many as you want, and the zip method will just group them together. And the next functions, I believe you know what is functions, right? The functions is something we defined, and to operate the input, get some outputs. Here I would like to introduce a few usages of functions when you do not know the details about the function. The first case is that if you do not know how many arguments that will be passed into your function, of course, try to avoid such case, because if you want to define a function, the best way is that you clearly know the objective of the function. So you should clearly know how many arguments are there. But just maybe in some early development of the models or early implementation, still you don't know how many arguments that will be passed. Just add an asterisk, this star symbol, before the parameter name in the function definition. If you do this way, then the function will receive a tuple of arguments and can access the items accordingly. Here is a function like this. We define a function print months. Now, we don't know how many arguments that will be passed. So we directly use this asterisk symbol together with this parameter name months. And what this function does is print the last month is and month -1. So anyone knows what this index -1 means? Yes, please.
Access the last element of a
Yeah. Yes, correct. Excellent, very good. The -1 means the last element. Because recall that for this parameter month, actually we don't know how many arguments will be there, right? So actually we don't know the order of the last elements, but don't worry, we just use this -1. So we don't care, currently we don't care like the length of this month because we don't know yet. We just use -1 to index it. So the last month is, and concatenate with this month -1. And when we really use this function, suppose we use it in this way. Now we print months together with such tuple from January to December. And if we run this way, it will print the last month is December. So because it goes into the print months and we use asterisk, so it's okay. It will accept the whole month such tuple and extract the month -1, the last element, which is December here, and print the last month is December. So this is the case if you don't know how many arguments there will be. The second case, if you do not know how many keyword arguments that will be passed into your function. In this case, we don't use any keyword argument. Keyword argument is that when you define the function, you already define like the name of the argument. Argument is not the same with parameter. A parameter is something, some value you pass into function. Argument is what you already defined in your function. So here is an example. If you do not know how many keyword arguments, then add 2 asterisk before the parameter name in the function definition. Then in this way, the function will receive a dictionary of arguments and can access the items accordingly. So the function like this, print month, we add 2 asterisk before the parameter name month. Now we use 2 asterisk. That means actually we expect there will be some keyword arguments. So inside this function, it does this thing, it print the month is concatenate with month name. Now name is a keyword argument. So it's a keyword, right? It's different with you use some index to retrieve the elements in months. You use some keyword to retrieve the elements in the months. And this keyword, of course, it will work as a key to extract values from the dictionaries. And then concatenate with, it is the, then concatenate with month order. We use another keyword, order, to extract some values from months. We also extract month days. So there is another keyword called days in this month. This is that at this moment, you don't know how many keyword arguments there will be, but at least you know there are some keywords called name, order, days. But there may be many other, you don't know. So you just add this to asterisk before months. And let's see the example how you use such function. Suppose we print months and give all these keyword arguments and parameter values to it. So name equal to September. Name here is the keyword argument. And order equal to none. Order is the keyword argument. And then days equal to 30. So days is another keyword argument. After that, it goes into this print months and try to extract the month's name, and we'll find that, okay, the name's value is September, order's value is none, and this day's value is 30 for this input month. So it prints out such information. The month is September, extracted from the name. It is the ninth month. Here, none extracted from the order. It has 30 days. So now the days extracted here. So this is another usage. Basically, the two usage differ in the case that whether you have keyword or not. If simply you will use some arguments that do not contain any keywords, you use this one, just one asterisk. But if you already know you will have some keyword arguments, you just don't know how many, then add these two asterisks so that you can directly extract the keyword values. Yeah. So any questions so far regarding the how to use the functions for these two usages? Great. If no, then let's move on to the object-oriented programming. If you have taken the C++ object-oriented programming, I think the concepts here will be very familiar to you. But still, it will be a little bit different in Python. So let's see. So the object-oriented programming, or simply call it OOP, is a way of structuring a program by bundling some related properties. That means data and behaviors with say functionality into the individual objects. And the fundamental concepts of OOP can be introduced via the use of class and objects. So in Python, if we want to define an OOP, then we need to use this class, this keyword, to create some OOP object. So let's see what is class. So class is a terminology used in Python here. A class is a user-defined data type from which the objects are created. And note that it's just created by this keyword class. Whenever you want to create a class, you just claim the keyword class. It's like if you want to create a function, you use the keyword def, the def, right? And the class provides a means of bundling the data and functionality together. So here data is the instance variables inside a class. Functionality is the methods inside the class. Instance variables, they are the variables that belong to an object. And they are always public by default. But don't worry, actually, if you want to turn it into private or protected, we also have some ways to do that. Later on, I will introduce that. But by default, all these instance variables are public and can be accessed using the dot operator. I will show an example later. For the methods, they must have an extra first parameter self in the method definition. Usually, this is by default. So if you want to create a method inside a class, note that it has this extra first parameter self. This self refers to the class itself. So that means it can access the class itself, like access its own instance variables, its own other methods. So that's why we put this self here, referring to the class itself. And note that we do not give a value for this parameter self. When we call the method, Python provides it because this self just refers to itself. The instance variables and methods are accessed by using the object you created from the class. And we usually add this init method in the class. If we want to define a class, we just at first use this init method. This is similar to the constructors in Java or C++. The constructors are used to initialize the instance variables of objects. Because if you want to claim there are some instance variables of these objects, usually you need to give some initialization values, right? So that they will accept, okay, now the initializing values of these variables are this, and after that they can operate on these values. Until now, all these are just some abstract knowledge. Let's see the syntax. We define a class with instance variables and methods, and of course a constructor. Like I said, the keyword here, class. So you must first claim this class keyword here, meaning that, okay, now I will define a class, then put this class name here, the name of the class. And the first method usually is the constructor or the init method. So usually we will get this define init. The first actual parameter is always this self. And maybe we will give some other arguments here, just some method parameters or the variables. And inside this init, what we do is we initialize the instance variables. Instance variables, for example, if we have the instance variable 1, we must use this way to initialize it. We must use this self dot instance variable 1. Only if we add this self dot, we mean that this instance variable 1 is an instance variable. It should be accessed by the object itself, so self dot. And assign a value 1 to this instance variable 1. This is the initialization. And for the self dot instance variable 2, also assign a value to it. Of course, if you have multiple instance variables, just do the similar way to initialize their values. After this constructor init, you can create some other methods, the class methods as you like. For example, here we define another method like method 1name. Just create another method here. And the first actual parameter is still self. And give some another arguments here. And possibly you will write some statements inside this function, this method. And similarly, you can define as many methods as you like to perform what you want this class to do. So this will be the syntax of class, how to create the class. The class, you have these instance variables, and you have these methods like method name, method 1 name, method 2 name. These are the methods you have, and you also should have this constructor, the initialization part. Then if you already define a class, of course you will want to create an object according to this class, and possibly you will call a method and modify an instance variable for this object. And this is the syntax how you can do that. So recall, until now we already have the class, which is called class name, and you need to create an object. So simply write this way, object name equal with class name, and inside this parentheses give the arguments as parameters. In this way, you can create an object which is named with object name from the class name you have just defined. And if you want to call a method here, a method from it, then use this way, object name dot method name, and give the arguments. Here is a key thing, is that outside the class, that is possibly now you are already going into the main programming part outside the class definition. If you want to call a method in these arguments here, don't need to give the first parameter self. So if you call it outside of the class, in these arguments, it does not contain self. The self is only defined within the class as a first actual parameter, refer to the class itself. Then, where does this self go, right? Why in the class definition we need to use it, but outside the class we just simply omit it. It cannot disappear. Where does it go? This self goes here. this self refers to this object name. That is the object you created from the class. So if you directly call object name dot some method, then that means this self already refers to this object you created, you claimed. So that's why here in these arguments, you don't need to put the self there. This is the way you can call a method. Then possibly sometimes you want to modify an instance variable, right? Even though we know in the class, when you define it, you already initialize the instance variable values, but sometimes you just want to modify it. Things change and you modify it, so you can modify it in this way: object name dot instance variable name, and assign a new value to this instance variable. You want to assign it. And now this object name will also replace the previous self. Like in the constructor, if you want to do initialization, you use self dot instance variable. But outside the class, you use the object name dot instance variable to access the corresponding instance variable. This would be the syntax of classes. Then let's see an example so that you can have a better understanding about how it works. So we import a library math, and we define a class circle. Now, in the constructor, we give the arguments radius to it. Of course, the first one is by default self, and then we give the radius. So in the constructor, we initialize the variable, instance variable, self.radius, let it to be radius. So that means we accept some value from the argument's radius and assign its value to self.radius. After that, we define two methods for this class. The first method is called area. So by default, it only has one parameter self, the class itself. And in this function area, we return math.pi, that's that number 3.14 something, that number, we get it from the library math. Math.pi times self.radius square. So basically is that after we know the radius of the circle is this value, then we compute its area according to the mathematical formula here. Another method we define is circumference. So in the circumference, again, it just has one by default parameter self. And we return 2 times math.pi times self.radius. We just compute the circumference of the circle according to the mathematical formula. All right, this is a simple class, right? It has only one instance variable, 2 methods. And next, let's see how we can use this class outside of it. So first, we define an object, which called circle object. This circle object is created from the class circle, and we need to pass some arguments as a parameter to it 10. So after that, this class circle immediately accepts such expression and creates an object, circle object, with the radius equaling to 10 because we give the value 10. Then we can modify the circle object's radius to 100 by modifying its instance variable, even though at the beginning we give the value 10 to it, right? So after initialization, the circle object dot radius will be 10, but we directly modify it like this. Now, circle object dot radius accepts the new value we assign to it, 100. We modify it. Then we can call the method. So we print area and call circle object dot area. So that inside the parentheses, it should we should pass the parameters to it. But since the area actually only has one parameter, that's the self. So here, that's why inside the parentheses is empty. You don't need to write the self there. But still, you must have this parentheses here. Parentheses mean that it's a function, it's a method. You cannot omit this parentheses even though it's empty. So circle object dot area, then we call this method area, And by computing this one, note that the self.radius is already changed to 100. So after computing, it will print area 31,415, something like this. And similarly, we call this circle object dot circumference. The parenthesis inside is empty because we don't need to write this self. And after computing, it will return this circumference 628, something like this. So this is the example of how to create a class. After you have a class, how to create the object, how to modify the instance variable, and how to call all the methods inside of a class. So any question now? Great. If no other question, let's take a 5-minute break. After the short break, we will continue with the public, private, and protected members.
可以看到。
All right, let's come back to the class. Yeah, just now received some very good questions, so I'd like to clarify a little bit. Yeah, the concept of the instance variable. Instance variable means the variable that belongs to the class only. Like here we have the class circle, and we have an instance variable self.radius. So that means the self.radius such instance variable belongs to the class circle only. If outside the class you want to access the instance variable, you need to create an object. Like here we create an object, circle object from circle, and after you create an object from the class, you can access the instance variable of that object. Like here, circle object dot radius is the instance variable for circle object. Self dot radius is different from radius here. Radius here is a parameter for the constructor. Like this constructor init receives such parameter radius. After that, of course, it knows what is the value of the radius because you pass to it. And then this instance variable self.radius will get the value from the parameter radius. These are two different things, even though we use the radius to assign values to self.radius. Because we add self.dot as a prefix. Then self.radius itself is an instance variable. And this instance variable is supposed to be accessed by all the methods inside the class. Like here, we define the method area, right? Actually, as you can see, we don't give self.radius as a parameter, but we give self. If we give self as a parameter to area, then basically this method area can accept all the thing of this class circle because you already give self. So that's why actually inside the method area, it can access self.radius because you give self as a parameter. And similar for the circumference, you give self as a parameter and you can access self.radius. Self.radius, the instance variable. Suppose sometimes you omit this self.dot. You simply forget that. If it's in this case, somehow you just mistakenly forget this one, then what will happen? It will cause error if you call this area, because radius is not defined for the method. Right? For the method, it accepts the parameter self, not radius. Radius is the parameter you pass to the constructor, not to other methods. So if sometimes you just make such a mistake, then it will cause error. In this case, please check that actually you use the instance variable self.dot. So always use the self.dot. So if you write in this way, it simply give you some error. All right, yeah, just a few add up. Next, I want to introduce the public, private, and protected members. Before, we mentioned that all the members in a Python class are public by default. That is, any member can be accessed from outside the class. To restrict the access to the members, actually, we can make them protected or private. Protected members of a class are accessible from the class within the class, of course, and also available to its subclasses. Later on, I will also introduce a little bit about subclasses. And by convention, Python makes an instance variable or a method protected by adding a prefix single underscore to it. If you see that such a prefix, this single underscore, then you should know that this instance variable or this method is protected. This is Python's rule. They just regulated it to be such a prefix. And we can also create some private members. Now, the private members of a class are accessible from with the class only. Even for subclasses, they cannot access private members. And by convention, the Python makes an instance variable or a method private by adding a prefix double underscore to it. So note the differences. Single underscore protected, double underscore private. If no underscore as prefix, then by default they are public. Note here we use a word by convention. By convention means that the responsible programmer, which I expect you to be, would refrain from accessing and modifying instance variables prefixed with the single or double underscore from outside its class. That means you should keep the rule in your mind and you shouldn't do such thing. But if they do, sometimes still works. Still works doesn't mean that it will fulfill your expectation, but that simply means it won't cause error if you do such thing. So let's see some examples here. Here we define a class Pokemon, and the instructor takes such parameters, of course, self is self, and this is a keyword argument, as we can see. The name is a keyword argument. Here we can give some default value to the function. Of course, if you don't have this equal to Pikachu, you only give name, it's also okay. But if you give this name equal to Pikachu, that means it's okay that you don't pass the value of name when you create the class Pokemon, because it has some default value. All right, this is the first parameter you need to give it, and the second is the unindex is 0, 0 to 5, and also it has another argument types, which is by default electric. It's simply we have some by default values for all the instance variables here, because sometimes it's okay just we don't give any values to it. And then we assign values, right? We need to do initialization. We assign values to the instance variables. As we can see now, all these instance variables are private instance variables because we add double underscore as prefix. Here, self dot double underscore name gets the value from name. Now it's a private. We simply use double underscore to indicate it's private. And the same for self.double underscore index and self.double underscore types. All these instance variables, now they are private instance variables. And we define another method for this class, print, and it accepts self as parameter. So basically, it just prints the information for this Pokemon. Print Pokemon and print name concatenated with self dot double underscore name, and also index and type. So this is the class Pokemon we defined. Next, outside of this class, we want to create an object from the class. Suppose now we create a Varpix, such an object which is from the class Pokemon, and we give the value Varpix 0037 and fire. Note that when you create such object, it's okay you omit the keyword if the keywords are in order with your constructor. So that means you give 3 values, right? The first one represents name, the second one represents index, the third one represents file. It's okay because they are in order with the constructor keywords order, name, index types. So basically this is the same with something like this. If you create it by give all the keyword, it would be the same. For example, you just let name be this warpix. And you let this index be this value, and of course you can also indicate, okay, the types is this file. So it will be the same if you give this keyword. Because actually these three values you give are in order of the constructor order. But the good thing about if you use keyword is that you don't need to follow the order. Like if you use like warpix, which is from Pokemon, index is something, type is something, name is something, it's also okay because you already give the keyword, right? But if you don't give the keyword, make sure it follows the order of the constructor's order. All right, now we create an object warpix, another Pokemon, and we try to print this Pokemon's information, like we print name, concatenate with this warpix.double_name. We want to access its private instance variable. This line of code we'll call arrow, because warpix.double_name is a private instance variable. You cannot access it outside of a class. It's already outside of class, right? And the same with warpix.double_index, warpix.double_types. All of these will just cause arrows. It will tell you that, oh, you are not allowed to do such a thing. They are private. And next is about then how about we change the value of these private instance variables? Can we do that? If you run these two lines of code, like now let warpix.double_names be a low-line warpix. Okay, you just change the name. Of course, after you change the name in accordance, maybe we also change the types. We know the low-line warpix is ice type, so warpix.double_types is ice. After you do this thing, you find it's okay. Wow, no error raised. You just smoothly run it, but does that work? Like, even no error occurred, do you really change the name and the type of this Pokemon? Like, do you really modify the values of some private instance variables? You will find that no, actually you do not change. If after this two lines of code, you call this method warpix.print, it's okay, it will print your information. But after that, you will find that the name of this warpix is still warpix instead of a low-line warpix. And the type of warpix is still fire instead of the ice. So basically, you run these two lines of code without any error, but that does not work. You didn't do anything successful to change it. The reason is that they are the private instance variables, even though you can do that, but actually you have nothing to do with these private instance variables. And that's why we say that the responsible programmers shouldn't do something like that. It's not that as long as you won't cause any error, you can write any code you want. It's not like that. Responsible programmers should keep the rules in mind and never write something like that, because even though this won't cause error, but actually it does not work. Then you may ask that, okay, then how to do that? What if I created some private instance variables, but still I want to retrieve and modify them outside of the class sometimes? How can I do that? Actually, we have some ways to do that. We need to define accessors and mutators to do that. So let's see what is accessor, what is mutator. So the accessors and mutator method, they are used to access the protected or private instance variables, which cannot be accessed from outside the class. Accessor methods, or sometimes we simply call them getters, they are used to retrieve the values of the instance variable of an object. When the accessor method is called, it returns the private instance variable value, while the mutator, or sometimes we call setter, the setters, they are used to modify the values of instance variable of an object. And these two methods, they can successfully modify, retrieve the private members. Let's see the example. Again, our class Pokemon and the constructor are the same. Now we initialize the 3 private instance variables. Next, we define accessors or the getters for each of the instance variable because they are private. The first accessor is for name. We define the method getName with the parameter self, and for this getName is simply return the value of the instance variable. So it simply returns self.double_name. Note that this is doable because the method getName is still inside the class. So at least for this method getName, it can get the value of the private one, right? Because it belongs to the class. And the same thing for index and types. So we also return the self.double_index for this getIndex and return self.double_types for getTypes. Now we define the 3 accessors to access the 3 private instance variables values. Then we try to define the mutators. Mutators is we sometimes want to modify the value of the private members. So for example, for the name, we define the function setName. It retrieves self, of course, as a parameter, and we give another parameter name to it. So name is something you need to pass to this method. And this is a new name you want to assign to the private name. So inside this mutator, it simply does one thing. Let the self.double_name be name. It gets the value from name and reassign the value to this double_name. So by this way, it can modify the value of this private instance variable. And we do the same thing for index and type. So we have the 3 mutators, set, index, set, types. So for each private instance variable, we define 1 accessor and 1 mutator to make sure that now we can retrieve and modify their values. And for this print, it remains the same with the previous method. We still have this print to print this Pokemon's information. Okay, now we finish defining the class Pokemon. It's a new class with accessors and mutators. Then let's see what has been changed. Again, we create an object Vulpix from Pokemon, give this name value Vulpix and index value 0037, types value fire. So now we create object Vulpix with these 3 instance variables. All of them are private. Now we want to get the values of these private variables, so we use such thing. Instead of directly get Vulpix.double_name, which is a private instance variable, we call the method getName. After that, it goes into the class, run getName, this method. Now this self, of course, refers to the Vulpix, the object we have created. And since getName is a method inside the class, so it can successfully access self.double_name. So it can return the name even though it's a private one. So after that, it will print, it can work and correctly print name Vulpix. The same thing will happen for index and types. So it will successfully return, okay, index is 0037, type is file. So it successfully retrieved the values of the private instance variables outside of class. And we can also try to modify the values of these private instance variables by using the mutators. For example, now we let a lowland warpix be a parameter we pass into the method warpix.setName, a lowland warpix. After that, it goes into this method setName, and name is here, a lowland warpix. We pass it to be the argument name, and it will change self._name to be name. And we can also mutate the types. So we just reassign the value ice to the private instance variable self._types. After that, if we print this information, that is, we call this print method here, you will see that now the information will be print Pokemon, name, a lowland warpix, index 0037, and types ice. And that means after these two mutators calling outside of the class, we successfully modify the values of some private instance variables. So this is how you can retrieve and modify the private ones just by adding the accessors and the mutators when you define the class. All right, we already run out of our time. So don't forget that tonight we will have an additional lecture class where we will continue with this lecture slides on the advanced Python. Later on, I will also make an announcement because some students told me that they live far away from the campus. So tonight's additional lecture class will be changed to mixed mode. You can come face-to-face or you can join it online. And don't worry, the recordings will be released afterward. So see you tonight.